Hello friends and welcome back to my channel. Myself Ashfaq, and in today's video we will see how to build the fully automated CI/CD pipeline using GitHub Action. In our pipeline, if the remote user uh, pushes the changes to the GitHub repository, then it will initiate the GitHub Action pipeline, and first of all it will fetch the code from the GitHub repository. Then the SonarQube analysis would be done for the uh, GitHub code, GitHub repository, and then Trivy file scan would happen for our code. After that, our GitHub action will build the Docker image and it will push that Docker image to the Docker hub. Then Trivy image scan would be performed for the Docker hub image, and then GitHub action pipeline would deploy the pods container on the Kubernetes. And after deployment of the resources on the Kubernetes, we will get the Slack notification onto our Slack channel. And finally, our application would be available over the internet through the Kubernetes service URL. So these are the steps would be covered under the build job of the GitHub action, and these all steps would be covered under the deploy job of the GitHub action. So let's start building our project. First of all, we will create the EC2 instance using Terraform. This is my Windows system in which I am having Terraform installed. You can refer to this video on how to install the Terraform in the Windows system. The link of this video is available in the description section. I'm having AWS CLI also installed in my system. You can download the AWS CLI from this link and install it in your system. I'm also having the Visual Studio Code installed in my system. You can download it from here. Both the links are available in the description section. I will create one folder called Swiggy clone resources, and the inside this folder I will create one more folder called Swiggy GitHub Action. On the VS Code, I will open this folder. I will create file
main.tf, and in the main.tf I will paste the content. So this is my mi. You can change the mi as per your region, and instance type would be T2 medium. This is my key name. In my AWS account I'm having this key pair. If you are not having, you can create one. And this is the tag name I'm giving to my instance. Volume would be 40 GB, and it is going to create the security group with this name, and it will create the inbound rule also in the security group, and it will open these ports, and it will uh, add the outbound rule also, and this would be the tag of my security instance, security group, sorry. So this is my main.tf file. So there is no need to create the VPC. It will create the security group in the default VPC of your account. I will save this file. After that, I will create one more file and give it the name provider.tf. I will paste the content in the provider.tf. This is my region. You can change your region as per your requirement. I will save this file, and now I will create one more file called install.sh, which is going to install the required softwares in the newly created EC2 instance. I will paste the content in my file. So first of all, it will update the system, then it will install the JDK in my EC2 instance, and it will install the Docker in my EC2 instance, and it will give the access to the user Ubuntu on the Docker, and it will run the SonarQube container on the Docker also, and this would be the port, external port for the SonarQube container 9000, and it will also install the Trivy on the EC2 instance, and at the end it will install the unzip also on my EC2 instance. I will save this file. Now I will go to my AWS portal. I will go to IAM users, create user. I will give the name cloud user. Next, attach policies directly. I will give the administrator access to this user. Next, create user. I will go to newly created user, security credentials, and I will click on create access key. CLI. Next, description I will provide cloud user, and I will click on create access key. I will go to VS Code and I will open the terminal. I will give the command AWS configure. I will paste the key from the AWS portal. I will paste the secret from here. I will download the file. Done. I will again go to terminal, and here I will give the command terraform init. Okay, then I will give the command terraform plan. So it is going to create these resources. If we give the command terraform apply, so finally I will give the command Terraform apply auto approve. If I go to my AWS console, EC2, so I can see the EC2 instance has been created, and this is the public IP of my EC2 instance. In this section of the video, we will configure the SonarQube and will integrate the SonarQube with the GitHub. I will access my EC2 instance from my local system. If I give the command docker version, so the Docker has been installed in my EC2 instance. If I give the command Trivy version, so Trivy is also there in my EC2 instance. If I give the command docker ps-a, so this is the SonarQube container running in my actually it is exited in my EC2 instance. I will start it. If I again give the command docker ps-a, so the container is SonarQube container is running in my instance. I will log into SonarQube by giving the IP address of the instance colon 9000 on which our SonarQube container is running. I will log in with the default credentials, which is admin. I will set the credentials. I will click on manually. Project name I will give Swiggy app, branch main. I will click on setup with GitHub Actions. So the uh, first thing it is telling us to create the credentials on the GitHub repository. So I will go to my repository. I will go to settings. Here under the secrets and variables, I will click on actions, new repository secret, and from here I will copy the name Sonar token. I will click on generate a token, continue. I will copy the token. I will paste it here, add secret. Now it is asking to add the Sonar host URL into our GitHub repository. So I will again go to my repository, new repository secret. I will copy the name from here. I will give the name here. I will copy the value from here and I will paste it here, add secret. I will click on continue. I will click here on other. Now it is asking us to create the file with this name in our repository. So I will copy this value. I will go to my repository, add, create new file. I will give the name which was copied from the SonarQube, and content also I will copy from here and I will paste it here. Commit changes. Next thing, it is asking us to create the file build.yml. I will copy the file name from here. I will go to my repository. I will again add new file. The name I will change to swiggy-build, and the content I will copy from here. and I will paste it here. I will remove these commented lines. I will click on commit changes. I will go to actions. So this is my file. I will go to my file, build. So these are the stages which has been completed, and this stage is running as of now. So job completed successfully. If I go to Swiggy app, I will click here on finish tutorial. If I go to projects, so you can see here my app is passed, and this is the uh, scan result for my app.
In this section of the video, we are going to integrate the EC2 runner to the GitHub, and EC2 runner would be our EC2 instance. So on the GitHub, I will go to settings, actions, runners, new self-hosted runner, Linux, and I will execute these all the commands one by one on my EC2 instance. Now I will execute the commands which are under the configure section. I will copy the first command and I will give it here. enter the name of the runner group to add this runner to. I will click enter here, enter the name of the runner. So I would like to give the name to my runner as the Swiggy-app. So it is asking to give the labels. So I would like to give the multiple labels to my EC2 runner. I will paste all the labels here which I want to give to my EC2 runner. So these are the labels I would like to provide to my EC2 runner. VTech box, Swiggy-GitHub action, and EKS-GitHub action. I will hit enter. I will hit enter here again. So runner has been added to our GitHub repository. Now I will go to my repository. I will go to this folder workflows. I will open this file. I will go to edit, and here runs on. I will paste self-hosted. So actually self-hosted is one of the label to my EC2 runner. Self-hosted Linux, and additional 3 labels I have given to my EC2 runner. I will commit changes. I will go to actions, build, job complete. And here also message is coming succeeded. If I go to SonarQube and do the refresh here. So this is the latest scan result for my app on the SonarQube. Now it's time to perform the Trivy scan of our code. I will go to my GitHub. I will go to workflows. I will edit this file. So as of now, there are two steps we have. One is for code checkout and one is for the SonarQube scan. So I will I will give the name to my these two steps. This is the checkout step and the another one is SonarQube scan. So I will give the name to that step also. And I will now go ahead and add the one more step into my YML file, which would be for Trivy FS scan. The name of the step is Trivy file scan, and it will save the result in the trivyfs.txt file. I will commit changes. Actions. So it's waiting for the job to be get pick up. I will run here .sh. job completed. If I go to SonarQube and do the refresh here, so it has been scanned just now, and this is the scan result of my code. On the EC2, if I go to cd underscore work directory, and inside this I will go to Swiggy clone. Again I will go to Swiggy clone directory. So here I can see I'm having the file trivyfs.txt, which is the scan result of my trivyfs scan step. I can view the scan result. In this section of the video, we are going to build and push the Docker image. I have logged into the hub.docker.com. I will go to account setting, personal access tokens, generate new token. I will give the name to my token. I will give the rights, generate. If we go to this URL, so this is the steps for the Docker build and push provided on the uh, Docker documentation. I will go to my GitHub repo. I will go to settings. secrets and variables, actions, new repository secret. I will give the name Docker Hub username, and secret would be my Docker Hub username. Add secret. Again, I will click on new repository secret, and the name would be Docker Hub token, and here I will provide my token, personal access token, which we have generated just now. On my Docker Hub, you can see there is no any latest image available. On my repository, I will go to workflows. I will edit my build.yml file, and I'm going to add one more stage for the Docker build and push. So this is our complete step for the Docker build and push. This would be the name of our image once it is pushed to the Docker Hub. I will commit changes, actions, build. It is waiting on my EC2 runner. I will run run.sh. Job completed. If I go to SonarQube and refresh here, so this is the scan result for my code. If I go to Docker Hub and refresh here, so you can see the image has been pushed here. Till now we have prepared our pipeline to build and push the Docker image. Now we will add one more step into our pipeline to scan the Docker image. I will go to my repo. I will go to workflow folder and I will edit the swiggy-build.yml, and at the end I will add one more step. The step name would be Trivy image scan, and it will save the result into the file trivyimage.txt. I will commit changes, actions, build. On runner I will execute run.sh. Job completed. If I go to SonarQube, so this is the code result, SonarQube scan result. This is my image, and on the EC2 instance, if I go to work directory and do the ls here, so this is our file scan result, Trivy file scan result of the code, and this is the Docker image result. So these are the results of the Docker Hub image scan. Now it's time to integrate Slack notification into our CI/CD pipeline. I will go to app.slack.com, get started. I will give here my email ID. I will enter the OTP. I will click on create workspace. I will give the name virtual hyphen techbox. Next. Next. Start with limited free version, as this is my lab environment. So the Slack workspace has been created. Using my email ID, and it's showing 30 days left in trial. I will go to drop down in my workspace, tools and settings, manage app. I will go to build, create an app from scratch. I will give the name GitHub Actions. I will select my workspace here and I will click on create app. Under feature, I will go to incoming webhooks. And here act activate incoming webhooks. I will make it on. And then I will click on add new webhook to workspace. Here I have selected new channel. I will click allow. I will copy the webhook URL and I will go to my repository on the GitHub. Settings, secrets and variables, actions, new repository secret. Here I will paste the copied URL and the secret name I will give Slack webhook URL. Add secret. I will close this tab. So this is the channel, new channel which has been added for the uh, GitHub action notification. I will right click on this channel, view channel details, channel name, edit, and I will change the name to the GitHub action. Now I will go to my GitHub repository, workflows. I will edit the YAML file and I will add one more step for the Slack notification. Name is send a Slack notification, and this is the channel, and this is the secret which we have added to our GitHub repository. Slack webhook URL. I will commit changes. Actions, build. It's waiting for the job to get picked on the EC2 instance. I will run run.sh. Job call failed because the public IP of my EC2 instance has changed. So I will update it in the GitHub repository. I will paste here the new URL for the SonarQube with the new public IP. Update secret. Edit. Commit changes. Actions, build. Okay, build job completed. If I go to my SonarQube and refresh here, so this is my latest SonarQube scan result for the code. And if I go to GitHub action, so you can see here we have the notification from the GitHub action on our channel GitHub action. In this section of the video, we will create the EKS cluster. For creating the EKS cluster, we will first install kubectl, AWS CLI, and eksctl onto our EC2 instance. I will go to my EC2 instance, and first thing I will install the kubectl. Now if I give the command kubectl version, so this is the kubectl version which has been installed in my system, in my EC2 instance. Next thing is to install the AWS CLI. If I give the command AWS version, so this is the AWS CLI which has been installed in my EC2 instance. Next thing is to install the eksctl into our EC2 instance. And if I give the command eksctl version, so this is the eksctl which has been installed in my system, in my EC2 instance. Okay, after this we have to create the IAM role, and we need to assign that IAM role to our EC2 instance. On my AWS console, I will go to IAM roles, create role, AWS service. Here I will select EC2. Next, this is my lab environment, so I will give the administrator access. Role name I will give eksctl underscore role, and I will click on create role. I will go back to my EC2 instance. I will select my EC2 instance, actions, security, modify IAM role, and here I will assign the role which I have just created, eksctl underscore role, update IAM role. So the role has been attached to our EC2 instance. Now everything ready for creating the EKS cluster. I will now go ahead and give the command to create the Kubernetes cluster. I will give this command eksctl create cluster name virtual textbox hyphen cluster. This would be my Kubernetes cluster name. I will hit enter. I will give the region for my cluster. I will give the node type for my cluster. I will give the node count for my cluster. This EKS cluster creation will take some time. So here the Kubernetes cluster creation completed, and if I give the command kubectl get nodes, so my cluster is ready, and these are the three nodes which has been created under my cluster. Okay, here I will do the refresh once. And I'm inside the home slash Ubuntu directory. I will go to .cube and I will download this config file. So this is the config file. I will rename it to secret.txt. We have built the Kubernetes cluster. Now it's time to integrate our Kubernetes cluster to the GitHub action. If I go to my GitHub repository, there is one file deployment and service.yml which will actually create the deployment and service onto the Kubernetes. So the first part is the deployment. So the kind is deployment, and the name of the deployment we have given Swiggy app. We have given the label also Swiggy-app, and it will create the container with the name Swiggy-app, and it will push the image. It will pull the image from the Docker Hub, and this is my Docker Hub username and the image name. Container port is 3000, and the second portion is the service. The service name would be Swiggy-app. This is the label we have given to the service, and service type would be load balancer. Port of the service would be 80. Target port is 3000, which is the container port 3000. Selector Swiggy app. This selector name should match with the deployment name. Then only it will create the service for this deployment. I will go to workflow folder. So this is my swiggy-build.yml file. So in my file, as of now, I'm having one job only, and the name of the job is build. So first of all, I will go to edit, and I will rename my first job from build to build, analyze, scan. And we will add one more job. We will give the name to our job as deploy. Needs build, analyze, scan. This is our first job name. After finishing this job would trigger. And under this job, this is our label of our EC2 runner, self-hosted. And under this job, I will add the steps. And in the first step, we are actually updating the kubeconfig file. This is my region of the EKS cluster, and this is my EKS cluster name. Then I will add one more step, which will actually deploy the deployment and the service on the Kubernetes cluster. I will correct the indentation. Okay, now it's look fine. So the step name is deploy to Kubernetes, and it will actually run the deployment and service YAML file, which I have explained earlier. And this Slack step I will cut from here, and I will add it at the end. I will correct the indentation. Okay, it looks fine. This is the channel name of our Slack GitHub action. I will rename my YAML file to swiggy build and deploy .yml. I will commit changes. I will go to actions. It's waiting for the job to get pick up. I will go to my EC2 instance, which is our EC2 runner, and here I will execute the run.sh file. Build job completed. I will go to deploy job. So deploy job also completed successfully. If I go to SonarQube and do the refresh here, so this is the latest scan result for my code. If I go to Docker Hub and do the refresh here, so this is the latest image pushed by the GitHub action to the Docker Hub. And if I go to uh, Slack channel, so in my GitHub action channel, this notification I have received from the GitHub action. I will go to EC2 instance. Here I will run the command kubectl get all. So this is our deployment swiggy-app, and this is our service. This is the external DNS name of my application. I will copy this and I will go to browser and I will browse it. So you can see here my application is able to browse over the internet. Everything has been set up. Now it's time to verify our GitHub Action CI/CD pipeline. So I have opened the git bash in my local system. I will first give two commands to define my user on the git bash. I will now clone my repository. I will go to my repository. So our YAML file is inside this directory. So I will go to this directory. GitHub/workflows, and here my file is there, Swiggy build and deploy. I will open my file in nano editor, and for testing purpose I will just add the dot here, control O and enter to save, control X to exit. Okay, changes has been done. I will stage the changes by this command. I will commit the changes. and finally I will give the command to push the changes to the remote repository. So keep in mind, after hitting the enter here, it may ask you to provide the GitHub credentials of your GitHub account. I will hit the enter here. Okay, so the changes has been pushed to the remote repository. I will go to EC2 instance. I will go to action runner directory and I will run the run.sh file. I will go to my GitHub repository. I will go to actions. So the changes are showing here. I will go to this commit. I will go to build. Build job completed and deploy job started. I will go to deploy job. So deploy job also completed. If I go to my runner, so both the job are showing succeeded. If I go to SonarQube and do the refresh here, so this is the scan result of my code. SonarQube scan result of my code from the latest run. If I go to Docker Hub and do the refresh here, so the latest image has been pushed to the Docker Hub. If I go to my Slack channel, so you can see here we have received the notification into our channel from the GitHub action. I will go to my EC2 instance and I will give the command kubectl get all. So this is the external URL for my service. I will copy this URL and I will browse it. So my app is running successfully onto the Kubernetes cluster. By this way, you can build the end-to-end fully automated CI/CD pipeline using the GitHub action. All the commands used in this video are provided in the description section. If you find any issue during the deployment of this project, you can ask me in the comment section. I will definitely try to help you out. In the next section, we will see how to destroy all these created resources. For cleanup, first of all, we need to delete the Kubernetes cluster. So kubectl get all command output was this this was deployment and this was the service. So I will delete the deployment first with this command. Then I will delete the service, and then I will give the command to delete my cluster. So this is my EKS cluster name and this is my region of the cluster. So my EKS cluster has been deleted here. Next thing is to remove the mapping of the EC2 runner from the GitHub repository. I will go to GitHub repo, settings, action, runners, remove runner, force remove this runner. Runner has been removed. I will go to my EC2 instance. The next thing is to remove the SonarQube. So this is our SonarQube container. I will stop this container. Container has been stopped. Now I will remove this container. Container has been removed. I will go to my GitHub repo, secrets and valuables, actions, and I will remove the two secrets related to SonarQube. Next thing is to remove the Slack integration from our GitHub repository. This is my workspace. I will go to tools and settings. I will go to manage. So this is our app which is installed on our workspace. I will click here and I will do the install. app has been installed. So this is my channel. I will go to settings of this channel and I will click on delete this channel. I will go to GitHub repo and I will delete this Slack webhook URL. Then I will remove the mapping of the Docker Hub. So under Docker Hub, I will go to my account setting, personal access token, and I will delete this token which was created to integrate the Docker Hub to the GitHub. And then from my GitHub repository, I will delete the Docker Hub username. I will delete the Docker Hub token. So all the secrets has been removed from the GitHub. Now I will open the VS Code. Actually now we need to destroy our EC2 instance which was created through the Terraform. I will right click on the main.tf, open in integrated terminal. So this was the history of our deployment which has been restored here. I will give here the command terraform destroy, which will delete my EC2 instance. I will accept it by typing yes. Okay, EC2 instance has been deleted. If I go to my AWS console and do the refresh here, so you can see EC2 instance has been terminated and these were the nodes of the EKS cluster which has already been terminated. Now I will delete the IAM user and the IAM role which was created. I will go to IAM users. I will delete this user.
I will go to roles. I will delete this role which was created by me. So everything has been deleted here. Hit the like button if you find this video helpful. Follow me on the LinkedIn. I share multiple useful resources on the LinkedIn also. A lot of effort went behind this video. So do subscribe to my channel to encourage my work. Share this video with the friends and spread the knowledge. I will see you in the next video. Thank you.